Okay, today's lesson is looking at multi-rule questions, which we kind of touched on last lesson, and it's basically taking all the rules that we have visited in the last few weeks and putting them together to be able to solve bigger problems. Now, on your lesson OneNote page, there is a file called Angle Rules. That contains a Word document with all these rules all set out with an example. It'd be a good idea if you could to print that off and have that beside you as you're going through some of these questions. As you can see, the number of different rules is starting to add up, and it's always good to go back and have a look. I always find that these questions are really puzzles. It's a case of just finding the first part or a starting point, and then usually you lead your way to find the answer. And really, a lot of the time, it's just practice, just trying to hone your skills and trying to look for what you can identify. Generally, as a informal rule, 9 times out of the 10, a lot of the rules, if they're hard to remember or they're hard to remember to implement, is that while most of the diagrams aren't to scale, and you certainly can't use a protractor to measure the angles, generally if they look the same, they usually are the same. So if you look at an acute angle that's roughly the same size as another acute angle, there's a very good chance if you had to guess they would be the same. The other thing to keep in mind as well is you can always if they aren't the same, generally they add up to 180. If you look at a lot of the rules talk about 180 all the way through. So if it's difficult, you can always revert and guess that way. Now, I'm certainly not saying that's the way you should attempt to answer all questions, but if you're struggling for a starting point, maybe that's a good way to start. So get that Angle Rules page printed off if you can, or certainly once we would get back to school. So the first question we're going to look at is polygons and straight lines. And this is kind of like a question that we looked at before, is that we have a number of angles we need to work out, and then we need to come up with reasons. So first of all, A, we should be able to work out is equal to 63 degrees, and that's because it's vertically opposite angles. So straight away that's 63. Then because 63 and B is on a straight line, we know that B must be equal to 180 minus 63, which is equal to 117. So the other option that we've got is looking at C. Now there's a couple of ways you can actually answer this. I'm going to go for the more exotic, is looking at C. So C plus 28 must be equal to B. So I'll write that out. So B must equal C plus 28. And the reason for that is exterior angle of triangle. So we can see that's a straight line. That's B is the exterior angle. So if we rearrange that, especially now that we know that B is 117, must be that C is equal to 117 take away 28, which means that C must equal 89. And there we go, and we've got the answer there. The other way that this answer has worked out C is that it's used the fact that this is a triangle and that we could look at the sum of the interior angles add up to 180. So you can see, again, talked about this before, there's usually a number of ways that you can solve them. As long as you've got the correct reasoning and the correct answer, you're fine. And also, it's not always the case, but generally if you have a question like this, if you follow it alphabetically, it usually tells you the way you need to go. So again, here's another question with polygons and straight lines. So we've got a triangle, we've got some other notation. What I want you to do is just pause the video and give it a crack, see if you can work out what each of those angles are and how you would work them out. So pause the video now and see how you go. Okay, so hopefully you gave that a crack. The key thing I would have looked at straight away was the fact that there's these double lines. What do those double lines mean? Those double lines mean that it's it's an isosceles triangle, which the base angles of the isosceles triangle are equal. So then it sort of makes it relatively easy. I can work out D because it's angles on a straight line. So that gives us 138 because D and 42 should add up to 180. And then lastly, F is equal to 96 degrees because we've got the internal angles of a triangle. Okay, and the other thing that we can check as well is that this angle and this angle together should add up to this angle. So 42 plus 96 gives us 138. So again, it's another way we can check whether we've got the right answer or not. So here's a tricky one. It's using a number of different bits of information that we have to deal with. So I'll give you some time to look at it, see if you can work out some of the angles, and then we'll go from there. So pause the video now. Okay, so hopefully you gave that a go. So the key thing is decagon, so it means it's 10-sided. So the easy thing to do is use the fact that we know of any shape equals 360 divided by how many sides it's got. So 360 divided by 10. So G is an external angle. So the easiest thing to do is say that G is 36. And then that makes it, because G and H are on a straight line, must be 180 take away 36, which equals 144. Okay, now J and K are a little bit more tricky. So the key thing that we need to think about is that this point and this point, between those points, is one side of our decagon. Okay. The other thing is, for want of a better word, this line here is a radius. It's not, but that's for a circle, but it's the equivalent of for a decagon. And both of those lengths are the same. So straight away, that should indicate to us that we can use the isosceles rule. So that's got to be K as well. So is there a way that we can work out one of those answers? Now, one of the options is to know that we know H is 144. Well, to work out K, what we could do is go 144 divided by 2, which is 72 degrees. So it means K is equal to 72 degrees, and then we can use that to work out J. Another way that we could work out J is that if I continued this on, okay, all of those angles would be J. How many of those are there? There's 10. So J is equal to 360 divided by 10, which is 36. Now, it is a bit of a coincidence that we've got the internal angles, or half the internal angles, and the exterior angles are the same, and all those sorts of things. But you can see there's a number of different ways that we could have solved that. Be mindful of this one as well. That way of finding J, where you do the number of angles in the center around a point, that is, it is quite common to turn up in textbooks. A lot of maths teachers quite like to show off a bit with it because it is quite a clever way of finding it. Because it's not necessarily a rule, it's just one thing that you can use the rules to be able to prove. So if we just double check our answers. Okay, so sum at the points 360, then all tens are, yep, so, and then the base angles of the isosceles. So they didn't find K the way I did by halving the interior angle, but if you found J, you would have found it that way anyway. Okay, let's have a look at another problem. I'll give you a moment to pause the video and have a crack at it. So find A, B, and C. Okay, hopefully you gave it a go. First of all, A, we can use this. That we've got a parallel line here, a transversal line that runs this way. So A must be equal to 81 degrees. The other thing we can do with that is we could then use that to work out C. So C is going to be equal to 180 take away 81, take away 43, which gives us 56. And then we've got to work out B, as we can use the interior angles of a triangle. So B must be 180, take away 56, take away 81, which is 43. Yes, and I should have spotted that as well. That, and I'll change color to show it. That this line here is a transversal line, and this is one parallel line, this is another parallel line, and you can see that there is an F shape for 43 and B, which means it's corresponding angle. So again, another way of doing it. Last question. I want you to have a go at this one, see how you get on. It's actually a really simple question, but you sort of have to think outside the box. So pause the video and see how you get on, or take a guess. Okay, hopefully you gave this a crack. So the trick is with this one is don't be afraid to add information in. So this one is missing a vital piece of information which I can add is that if you add a parallel line, that suddenly creates a Z for those angles, and it creates a Z for these angles. In other words, this one must be 26 and this one must be 43. So therefore you end up with the sum of those two, which is 69. So don't be afraid of adding information like that or adding lines. Make sure you use the correct notation. Notice how when I've added that line, I've also said that it's parallel, and it suddenly creates that one. So that's the end of the lesson. If you go back to the lesson page, there's some worksheets for you to complete.